All right, welcome back for our next and last session of today. This is going to be, our session is Innovative Diagnostics, and our chair is Brittany Stevens. Dr. Stevens graduated from UC Davis Veterinary Medicine, UC Davis School of Veterinary Medicine, that makes more sense, in 2013 with an emphasis in zoological medicine. Following graduation, she completed a small animal rotating internship in Ventura, California, and then a one-year internship in wildlife and conservation medicine at the Clinic for Rehabilitation of Wildlife in Sanibel Island, Florida. From 2015 to 2017, she returned to UC Davis and served as a staff vet in the Aquatic Animal Health Department and was then the inaugural participant at UC Davis Aquatic Animal Health Fellowship Program. Dr. Stevens is recognized as a certified aquatic veterinarian through the World Aquatic Veterinary Medicine Association, or WAVMA, and is a diplomate of the American Board of Veterinary Practitioners, certified in fish practice. Congratulations to all of those things. She is currently employed at the Aquarium of the Pacific in Long Beach, California, where she is responsible for providing veterinary services to the aquarium's diverse collection of over 14,000 animals. Her research interests include diagnostic imaging, infectious diseases, wound healing, and anesthesia of aquatic animals. Welcome up, Brittany, to get us started.
Hi, everyone. Hope you're excited for a very fun and diverse session. Our first speaker today is Dr. Barb Lenahan. Dr. Barb is the Director of Animal Health and Welfare at the National Marine Mammal Foundation. Barb has worked for NMMF as a clinical veterinarian since 2017, caring for the U.S. Navy's dolphins and sea lions. Prior to joining the NMMF, Barb completed a small animal internship at MSPCA Angel Animal Medical Center in Boston, Massachusetts, and a postdoctoral fellowship at the Vancouver Aquarium in Vancouver, British Columbia, Canada. She received her DVM from the University of Florida, and she became a diplomat of the American College of Zoological Medicine in 2023 with a focus in aquatics. After 9 years as an aquatic vet, Barb is actually shifting gears a bit. In a couple weeks, she will be starting a veterinary cardiology residency at Angel Animal Medical Center in Boston, after which she hopes to continue advancing aquatic animal cardiology. Barb is also the IAAAM board member for communications. Please join me in welcoming Barb.
All right. Thank you, Brittany. Good morning, everyone. Thanks for being here. Apparently, I was front-loaded in this talk because I'm known to be long-winded, which I can't believe. So we're just going to dive right into it. I'm really excited to talk to you today about this project I've been working on with a big team for about 4 years now, developing a mobile dolphin ECG. And so you might be wondering, well, who gives a flip about developing a mobile dolphin ECG, unless you're maybe me or the 2 cardiologists in the room, or maybe Craig Harms. And so I'll take you back to 2021, darker times, IAAAM during COVID, where we were virtual, where I presented on this dolphin on the left here, Blue, who's absolutely perfect. And she was diagnosed back in 2018 with sustained second-degree AV block that progressed to being high grade. And we talked in this presentation about the workup, we did an atropine response test, and then it started progressing. And so we're not going to spend the whole time talking about Blue, though I could, but just to quickly encapsulate a little bits of her case history, because she was really the impetus for why we wanted the ability to have a mobile dolphin ECG that now benefits dolphins, of course, other than her. So looking at the ECG, you can see here, the important thing is that those teal arrows are pointing to the P waves when the atria are contracting. And then those green arrows are pointing to the actual QRS complexes when the entire heart is actually beating and pumping blood to the rest of the body. And importantly here, there are 2 P waves for every QRS complex. So her atria are trying to beat twice for every time her heart actually successfully pumps blood throughout the body. We then were monitoring it with pretty much weekly ECGs for years to look for progression, and found that starting in 2020, we were seeing some progression. And so here, those darker blue arrows are showing 3-to-1 conduction, meaning 3 P waves for every QRS complex. And so with this advancing, we really wanted to be able to see not just dockside what her heart rate was doing or out of the water, but what is it doing under a variety of conditions. And so this is a picture here of the previous ECG capabilities that we had. So this is using the Dextronics VET ECG, which is made for dogs and cats. And we kind of jerry-rigged it in-house and took those ECG electrodes, embedded them in silicone suction cups. And you can see Blue's wearing them here, and it transmits via Bluetooth to a device. So it works well, but it is very prone to motion artifacts, whether it's blue moving or even slight wakes will cause a lot of motion interference, making the ECG really hard to read. And then as you can see, she has to be next to us. She can't swim away with this. And so we really highlighted the need with her case for, okay, well, how can we better monitor her during things like exercise, during sleep, to better assess her arrhythmia and treatment. So cut to 4 years ago, 2021, the Office of Naval Research put out a call for proposals to make wearable ECG technology to help the Navy's dolphins to better improve our cardiac monitoring capabilities. And so we, with the National Marine Mammal Foundation, along with this company called Luna Labs, they're a biotech engineering company based out of Virginia, we teamed up and we were awarded an SBIR grant to work on this capability. And so we decided to leverage the traditional Navy dolphin harness design. You can see that in the left photo here, the red thing that this dolphin is wearing, because they're already accustomed to wearing it and you can affix different things to it. So we decided to embed the ECG in this, essentially attach it to this because they're already used to wearing it. They can wear it swimming and diving in the open ocean. And then perhaps even more importantly, the very smart folks at Luna Labs decided to use this novel idea to make an ECG vacuum cup where there's actually active suction to maintain that electrode in contact with the body and get rid of a lot of that motion artifact and saltwater interference. So initially we went through 2 years of just development and lab time. So there were no dolphins involved in this step yet. We just went back and forth making prototypes in their lab, testing in their lab. And then in the phase 2 effort, we had 2 years that we have just completed of iterative prototype testing. And we'll quickly walk through what the iterations of these prototypes looked like, as well as data collection and improving the end user interface and software. So to quickly just walk through what the prototypes looked like, this is the first system, and you can see it is still tethered in this version. So the Black Pelican case has the actual pump housing in this version. It's being attached to the dolphin, and this step was really important for us to figure out, okay, how much vacuum do you actually need to apply to get those electrodes to stay firmly adhered to the skin without causing any trauma, of course, making it comfortable, making sure the dolphins tolerate it well, and then optimizing lead placement. And we used the modified base apex lead positioning that Dr. Harms described back in 2013. This was the first harness version back in 2023, where you can see there's one central housing, and Blue's demonstrating it here, wearing it open water, where it was one backpack that contained all of the housing for this. It was kind of heavy, a little bit clunky, but we started our open water and in-pen testing in this phase. Cut to the next prototype in 2024, where we actually split it in two. So now we have the ECG backpack and a pump housing backpack. With this, we were able to make it smaller and lighter, and we were able to start with in-water and open water data collection as well. With the next iteration, we were able to make it even smaller, even lighter, and just make it user-friendly. So the engineers were able to add little indicator lights to tell me when the battery is dying or when the pump is dying. And now these are the latest prototypes that we have for 2025. So now we actually have 2 versions. We have the ECG that can be used as a standalone or harness-free version, and then it can also be put in the harness and used with the vacuum pump. And I did bring props, so if my lovely assistant will come out, she can help me demonstrate these 2. Thank you, Dr. Melissa Jablon. Yeah, Vanna White here. So you can see in the left picture, this is the scaled down version. For those of you in person, you can see it here. So instead of the vacuum pump housing, we just have these little black bulbs that you squeeze to maintain active suction when you need to. And so this is ideal for lower activity settings, sleep, out of water transport, wild dolphin health assessments. Hopefully we'll try it next week when the animals aren't moving a lot. And then this can actually put back into the harness. Instead of the bulbs come off, it hooks back up to the vacuum housing, and then the dolphins can wear it for higher activity things like swimming and diving in the open ocean. Thank you so much, Mel. And I'll have the prototypes at the next break if you want to see them in person. I'd be happy to show you. And then we also focused on the user interface. And at this point, we were able to work on the streaming capabilities. So as long as that ECG backpack is essentially above the water, we can stream it to a tablet and watch the live ECG recording. Regardless, it is recording throughout, whether it's streaming or not. So if the animal is underwater, we're still saving that data. We just can't see it in real time because of the salt water. Okay, so this video on the left here is just demonstrating the unit that Mel just had held up here is the scale down or harness free version. And this is Blue demonstrating it. You can see how perfect she is. She wants fish. And so I'm just suction cupping it to her dorsum. There's suction cups on the bottom of the ECG itself. And then you can see the 2 leads there. And this is just a 2 lead system for now. The very next prototype will have 4 leads so that we can hopefully get 6 vector tracings. But for now, it is a 1 vector recording that we get from these 2 leads. And then in this video on the right, in contrast, you can see it in the harness version. So this is a normal dolphin swimming in the open ocean, wearing it in the harness. And you can see she's very unbothered by it. The suction cups stay in place really nicely. And that pump detects the loss of pressure automatically. So if the cup starts getting knocked off, it detects the loss of pressure. And then this is a video here just to demonstrate, hopefully the sound will work, to demonstrate what it actually sounds like when the pump kicks in after detecting this loss of pressure to automatically suction that suction cup back down to the skin. You can see it's pretty quiet. It makes a little bit of noise, and most of the dolphins don't really care. Sometimes the first time they heard it, they went, "Oh, what's that?" And then they were fine. Okay, so we'll quickly walk through some of the applications and data collection that we've stepped through in this phase 2 effort. First, with comparisons to our old dockside systems, and then in enclosure monitoring, open water exercise and diving, transports and out of water procedures, as well as during sleep, which has been interesting. And throughout this phase 2 2-year effort, we've had 11 normal dolphin participants and 2 with known cardiac disease, blue, and then 1 other cardiac disease dolphin. So what I mean by the simultaneous comparison is we just wanted to see, is this as good as our old capabilities with that VET ECG that I showed you before? So I literally put both on this normal dolphin here at the same time, recorded ECG tracings. And I really like this example to highlight. We're in San Diego Bay, so wakes come in all the time. So a boat went by, wakes came in, and you can see the tracing on the bottom is the old ECG, where we're really prone to motion interference. You see that baseline is all over the place, makes that ECG really hard to read. The top is this new ECG with that suction cup attaching the cup to the skin much better, and it's not moving around at all. And so it's not perfect. There's still a little bit of kind of jaggedness to that baseline, but it's a lot better, a lot cleaner and easier to read. This is a video of Blue wearing the harness version in San Diego Bay. So you can see this is her swimming alongside a boat. This is her daily exercise that she gets swimming in the open ocean. When she is wearing the ECG harness, she does swim a little bit slower than she does when we take the harness off. She's a little bit faster. But otherwise, she's pretty unbothered by it. And it's been really awesome for us to see that her heart is able to compensate. She is able to actually speed up her heart rate when she does get excited. Things like seeing fish, seeing her favorite trainers, and swimming open ocean. And then this is an example of an actual ECG tracing from when she is swimming in the open ocean. So given that we're in the open ocean and it's kind of choppy water, it's pretty amazing that with this technology, we're able to get that clean of a tracing on a swimming dolphin. And then by comparison, this is just a normal dolphin wearing the harness, swimming only slightly faster. And this is a beautiful tracing, just showing the normal respiratory sinus arrhythmia. And then if you watch the top of the backpack in this video, you can see that as the dolphin comes up and takes a breath, there is a tiny bit of drag on the little ECG backpack part right there as she goes back down. But really, otherwise, it's pretty hydrodynamic and they seem very unbothered by it. This is a sped up video that I made just to show the capability to also monitor during transport and exercise. So this dolphin is wearing the harness with the ECG built in. It's turned on, it's recording this whole time. He's beaching out of the water. He then gets closed up and driven to his work site. He's dumped into the water at his work site where he's now swimming alongside the boat, still wearing the ECG and still recording. And then his trainer can ask him to practice working essentially and go look for things in the ocean so we can have him dive to known depths while recording the data the entire time and look for things like arrhythmias during diving. And then he beaches back into the boat. He's still wearing it. It's still recording. He doesn't care. And then he gets a little boat ride home and goes back to his enclosure. And then this is Blue during the first sleep study that we conducted. So this was last April 2024. And you can see we put a little chem light so we could tell where she was. So she's kind of glowing in the dark here. But we did an 8-hour sleep study because we really wanted to know how bad does her arrhythmia get when she's really relaxed and even sleeping. And I had been doing ECGs on her every week pretty much since 2018. And this was the first time I'd seen anything worse than 3-to-1 conduction by just doing one sleep study. So we were able to see worsening to 4-to-1 conduction, meaning 4 P waves for every QRS complex. And the lowest heart rate we saw with her was 17 beats per minute, which is adrenal squeezing. And this is an example of the ECG that we got there with that 4-to-1 conduction. So cut to this year, now that we have that scaled down version, we repeated the sleep study with Blue. And now that we have 2, we actually decided to do her and a normal conspecific at the same time. So this is an absolutely adorable picture of the San Diego Bay skyline and sleeping dolphins holding pecs while wearing these scaled down ECGs. And now that we have the streaming capability with the tablet, it was really cool to be 20 feet away from them while watching what their heart rates are doing while they're sleeping. And so again, for Blue, now I saw things on this sleep study, and this time it was brief, it was only about 2 hours, but I was able to see things that I did not see during the daytime, like this kind of scary 5-for-1 conduction. And now she is progressing a little bit more, and we did see 38 instances of 4-to-1 block, which we don't love. Just going through the data collected so far, we've collected almost 3,000 minutes of ECG at this point. This is still ongoing. About a third of it has been normal dolphins, and about 2/3 of it has been blue and another cardiac case dolphin for more prolonged studies. We have looked at the heart rates overall for these normal dolphins, both in pen and open water swimming. Nothing too exciting here. Most of the average heart rates have been 60s to about 100 or 115. Blue, by comparison, her average low heart rate is 28 and her average high heart rate is 50, which is a lot better than 17. We'll take it. And then also just looking for arrhythmias. So of course, we're scanning all of these ECGs to look for arrhythmias. And we have found that in 7 dolphins, they've had at least one abnormal beat during those 3,000 minutes. But they're rare, isolated APCs in 6 individuals. So not super exciting by themselves. And we have reported similar findings in wild dolphins a couple of years ago. And then there is 1 instance of second-degree AV block. And then blue, of course, has her sustained AV block, which we know and we're monitoring, but she's also having isolated VPCs and APCs now, and she is on pemobendin, and we're kind of trying to titrate up her dose. So this has been hugely helpful, using this at least once a week to try to look for increasing arrhythmia prevalence for VPCs and APCs to make sure we're not giving her too much pemobendin and driving her into other arrhythmias. So this work is still ongoing. We are continuing data collection. We have 2 more years of funding as of today anyways. Hopefully that funding will continue. And we're working on making the 4-lead version, as I mentioned. We're doing more open water swimming, diving to deeper depths as we work on making it pressure rated for deeper depths. And then continuing to work on the software and just make it user-friendly for us vets who are not engineers, improving heart rate detection features, and flagging anomalies. So you don't have to sit there and look through 8 hours of ECG. You can actually just flag when you need to review it. We're also working on applications to other cetaceans. So especially the scaled down version, you could pretty much put it on anything that's not covered in hair. And if you want to, let me know, we can try it. So next week we'll be in Sarasota for the wild dolphin health assessments, trying to show that we could hopefully use it for monitoring during that capability and just plop it on the dolphin's back and read the ECG on the tablet throughout to monitor their heart rates and their stability. And then commercialization efforts. So this SBIR phase 2 option funding is for Luna to basically, by the end, have a commercially available product that anyone in this room could purchase and use on an animal that they have under their care. So thank you so much, of course, first and foremost to Blue, who's the best dolphin in the world, and for piquing my interest in cardiology, and the amazing Marine Mammal Program dolphins and sea lions, and then of course, all of the vets and the vet techs, everyone at the Navy and the National Marine Mammal Foundation. And I don't think I have any time for questions, but please find me at the break if you have any questions. Right.
All right, thank you, Dr. Lenahan. Our next speaker is Dr. Sean Perry. Dr. Perry completed his undergraduate work at the University of California, Santa Cruz, then earned his doctorate of veterinary medicine from Western University of Health Sciences in 2013. Following graduation, he completed internships in both emergency and critical care and small animal medicine and surgery, and worked in private practice in the Florida Keys. In 2020, he completed his PhD at LSU School of Veterinary Medicine, focusing on reptile-assisted reproduction. Since 2020, he has been the associate veterinarian at Mississippi Aquarium while providing relief services to zoos and aquariums along the Gulf Coast. He's currently the president of the Association of Reptile and Amphibian Veterinarians. Please join me in welcoming Dr. Perry.
Thank you, Brittany, and thank you everyone for being here today. So I want to share some research that we've been doing here at Mississippi Aquarium with a technology that actually in the biological literature has been around for a while, but it actually allows us to some diagnostics point of care, which is considered leukocyte coping capacity. And it actually allows us to look at white blood cell function in real time. So as clinicians, we all assess white blood cells on a daily basis. We take CBCs in our comprehensive health assessments for all of our species. One of the things with these lower vertebrates, reptiles, fish, elasmobranchs, is what methods are being used to actually assess these white blood cells. That's really important, and actually the values that you get. And one of the things that's lacking is, do we actually understand what is occurring with each disease process with our white blood cells? And then, as we see in a lot of other species, you end up having better information with serial CBCs over time. Single time point CBCs can be misleading a lot of the time. So when we talk about leukocyte degranulation, one of the things as clinicians that we do is we have clinical pathologists assess this on our CBCs, right? And you send a slide to Nicole Stacy. She says you have toxic changes +1, cells are degranulating, sepsis, inflammatory reactions occurring. But it's a subjective assessment, right? You see toxic morphology, it's a +1, +2, +4. But there's nothing that's been available that's clinically applicable to actually assess how severe the actual degranulation event is. So leukocyte coping capacity originated in kind of in the biological literature to look at reactive oxygen species production from white blood cells where you artificially stimulate the white blood cells to degranulate on purpose. It was initially used to integrate the idea of stress and welfare. When we talk about integrating stress and corticosterone, or depending on taxa, your stress hormone, and actually white cells, there's a bunch of information out there looking at white cells and picking a different regression analysis to go with your actual hormone value. In here, we can actually, using LCC, you're actually able to look at how well those cells are challenged and they're actually degranulating and what magnitude that happens. This can be useful in true immunosuppression cases where the white cells aren't functioning appropriately, or maybe you have some genetic disorder that actually prevents them from degranulating. We see that in other species and in humans. Another thing to look at with this is whether or not we can actually use it as a proxy and looking at white blood cell counts and or the activity. We can get this information within an hour of a sample collection rather than going through and doing the whole CBC. Whether that aligns is something that needs to be investigated. And then also looking at this associated with stress in our animals. We can actually couple an elevated stress hormone level, depending on whatever species, to your actual functionality of the white cell, not just a number as to what the count is. So these images right here are examples of the point of care analyzers that can be used. You end up using a luminometer to actually detect luminescence. There's 2 models that are available right now. There's a 3M model and this Berthold model right here. And you're actually in real time detecting the production of reactive oxygen species from your white blood cells upon in vitro stimulation and comparing it to control. And one of the benefits of this for us, and I work with a lot of reptiles that are small, we only need 10 microliters of blood to do this analysis, which is very useful. So for batoids or elasmobranchs in this situation, you're going to be measuring granulocyte oxidative function for your granulocytes, finding eosinophilic granulocytes, coarse eosinophilic granulocytes, your neutrophils, your basophils. But when I'm going to talk about leukocyte coping capacity, I'm going to refer to relative light units, and that's the actual measure that you get from the machine and the change that occurs over time. So everyone who loves pharmacokinetics and area under curves, we're going to be talking about some of that too. So the values that we actually look for with regards to your objective measures from an LCC tracing is going to be your time to peak, highlighted here in that red circle, or in that red bar. Your RLU max, which is your relative light unit max, that's the red circle you can see here, which is the peak. And then your area under the curve, which in this situation, we estimated based off of trapezoid and what they teach you in calculus and undergrad. So this was initially a pilot study effectively to assess whether or not this is going to work in rays. That was the first question. Does it work for us? Will this ability to in vitro stimulate the white blood cells work and we get a reportable number and identify a true tracing? So our objectives were to determine if LCC would actually work in batoids and do these granulocytes actually degranulate with appropriate stimulation based off of what we were seeing, what we assumed would happen. And to assess if luminescence, our output value, your RLU max and area under the curve was actually associated with any hematology values. So as you can see here are our hypotheses. We hypothesized that this would occur in 3 batoid species, Count's rays, southern rays. Those are the most common species in captive collections. And then we also looked at our honeycomb rays. Made the hypothesis that the RLU max would be associated with our total white cell counts, our fine eosinophilic granulocytes, coarse eosinophilic granulocytes, and then also basophil counts, our granulocytes. Our RLU max would actually not be associated with any of the round cells or our low lymphocytes or monocyte counts. And then also the area under the curve would be associated with our total white blood cells, FEGs, SEGs, and then basophil counts. So methods, we had a total of 8 Count's rays, 7 southern stingrays, and 2 honeycomb rays. I'm gonna talk about the honeycomb rays completely separately because of the analysis and the conditions in which we took the samples. I'll get back to that in a little bit because I've got some caveats with those. So methods during our routine health assessments here at the Mississippi Aquarium, performed venipuncture in the wing vasculature. Samples went into sodium citrate for CBC at Zooquatic Lab, and then lithium heparin for the analysis with the LCC. So the LCC, when it was initiated immediately, in this situation, we used the portable luminometer. The control samples effectively, which is where you get your measurement from for a baseline with regards to the actual luminescence, was the lucinogen sample and some saline and some blood. And then the treatment was lucinogen, forbomethyl acetate, PMA, and then blood, which the forbomethyl acetate actually stimulates the degranulation event to occur. So then our data was collected over 50 minutes. So as with anything, statistical methods. So as anyone knows who knows Alexa, when I start talking about stats, this is the face I get. But you know, so I looked at the data for normality, log transformed it. Then when I talk about linear mixed modeling, she stares at me like this and tells me to go to my office. So my dependent variable in this situation was luminescence. Random variable was the ray. And then we were looking at the interaction with species and time. For the RLU max and then area under the curves, we did regression analysis. I just used commercial software for the analysis. So as you can see here, I've got the leukocyte coping capacity curve in a box plot form for our Count's rays. You do see a spike at 10 minutes with regards to degranulation occurring, and it's significant over time. So you do see that in the Count's, so we got a reliable curve to look at in these healthy animals. So same thing happened in our southern rays too. We did see a spike and then we did see a slow decrease over time. So looking at them side by side, there is actually no species difference with these 2 species, which from a clinical side, that might be a little bit encouraging, but the fact is I'm always going to caveat it. We got to validate in each species, but that's just the reality of it. So our regression analysis, so our dependent variables are white cells counts effectively and our RLU max. This is where statistics gets fun. Regressions were not significant except for, depends on where you pick your p-value, right? Or your actual p-value. 0.052 for your white blood cells. How do you guys want to round? You want to call it significant or not? Or do you just want to increase your sample size and make that p-value go down? So I'm calling it significant just for this talk. Probably get kicked back in review. But it also had a poor regression with a R square value of 0.28. But the other granulocytes or the white blood cells didn't end up showing any sort of regression. So area under the curve, nothing actually associated with area under the curve. So effectively with this study, we were able to kind of show that the LCC does work. This is the first time assessing it in an elasmobranch. the elasmobranch granulocytes actually do respond to PMA stimulation, and the luminescence that we get from this or changes over time. There wasn't a difference in the species, but I'm always going to caveat validate in the species first beforehand because it'll bite you in the ass. So it was pretty consistent in both species that the time to max RLU effectively was at 10 minutes, which is something that we've seen across species. We've done this in radiated tortoises, bog turtles before. And I'm calling a weak association between white blood cell counts and RLU max at this point, just to get a general idea and keep this going in my head. You know, it might be worth it. But there's the caveat, we did this in healthy animals. We didn't do this in an experimental setting where we're inducing stress. Okay, physical exam may provide some stress when we're flipping them over, obtaining blood, but we need to validate that experimentally. This is where I get back to our honeycomb rays. So if you look at the way these curves for Pete and Carl, Penske specifically, these curves go, you notice how they tend to end fairly either higher or close to the peak of the RLU. So the area under the curves for these are probably showing some signal that occurs. These animals were immediately post, what was that, 6-8 hour transport that we did it on these guys. You know, it would have been nice at the time to look at 1-alpha hydroxycorticosterone, but that's something that needs to be evaluated. This might actually have signal for area under the curve or max, and time may have a component into it. You are effectively exhausting the white blood cells in this scenario. You're going to have some sort of gradation as to how severe that happens, or if it even happens at all. So that's something to look at in the future with this kind of information. So in conclusion, the LCC worked, right? Cow-nose and southern stingrays and honeycomb rays all degranulated, their white cells reacted to this. However, an RLU max was almost associated with our total white blood cell count. I'm using that as a caveat because I'm not putting everything on it. We'll see what happens when we get more data, or we have some sort of experimental model to actually do this. So, however, based off of the data that I'm providing here, RLU max was not associated with any of the white blood cell counts. Area under the curve was not associated with any of the white blood cell counts for southerns and cow-nose. So effectively, my hypothesis was rejected for those. So our take-home message is this actually may be useful for future use cases to objectively measure granulocyte counts. We need to do more research on it effectively. This is the kind of the first step to integrate this test with health and welfare. We need to start looking at hormone concentrations for this too, and further experimental work needs to be done. Stressful events, true disease states, additional immune system function tests are important in this case. So I want to acknowledge Nicholas Huber and Bonnie Raphael for getting me kind of involved and giving me the secret sauce to getting this to work in these lower vertebrates, and then all of our staff and veterinary externs at the Mississippi Aquarium. Does anyone have any questions?
Sorry, we don't have time for questions right now. If you if you want to catch Dr. Perry after the session, or you can message him also on the Hoover app. Our next presenter is Dr. Ree Chang. They are staff veterinarian at the Monterey Bay Aquarium and collaborates with the California Department of Fish and Wildlife on stranded elasmobranch pathology. They're originally from Pittsburgh, Pennsylvania, received their DVM from UC Davis, then completed a small animal rotating internship in Southern California. They're particularly interested in elasmobranch and aquatic invertebrate clinical medicine and pathology, and can be found biking, doing local mutual aid, and being a jack of all trades, master of none with crafts after hours. Please join me in welcoming Dr. Chang.
Hello, everyone. We are going to do some more first step information sharing. So we've learned quite a lot from our invertebrates of the deep. So we opened this temporary gallery into the deep back in 2022, and oh boy, has it come to take over our lives. Last year, it represented about 15% of our caseload. So we're going to dive first into a couple case examples and then summarize some subjective diagnostic strategies and lessons that we've been seeing. So our first case is in the Japanese isopod Bathynomus doderleinii, and these were presented to me with the acute progression of ommatidial and cuticular lesions. We are seeing early signs seen on the left with these focal cloudy lesions of the eyes, some mild erosion of the cuticle, and eventually progressed to these deeply erosive, ulcerative and necrotic lesions. We are seeing pretty high morbidity and low to moderate mortality. So with cuticle and periocular scrapes, we identified a really high load of larval nematodes on cytology. And although larval nematodes certainly can be secondary invaders, we did confirm that these were truly invasive on histopathology. Just to highlight some of our anesthesia protocols, we typically do a clove oil anesthesia followed by a secondary method with intracelomic or intracardiac potassium chloride or ivermectin. They take a while to go down. You can also use a Doppler to help guide your intracardiac injections. We actually found a successful treatment for these cases. So we ended up combining albendazole and manuka applied topically to the eyes in what I like to refer to as honey goggles. And this was applied once daily for 10 days. Although it was quite labor intensive, this actually did fully resolve our issues. We didn't have any more mortality and had negative scrapes. We of course combined this with exhibit management like exhibit breakdown. We did also find that other treatments and shorter course of duration were not successful, so really that full 10 days was what was needed. Our second case was in both Japanese and giant isopods. So the initial case that I was presented was an animal who was flipping over, lethargic, fairly non-specific signs in our isopods. But then on a population level, we started seeing sharply increasing mortality rates. And what we were seeing seen below, so we have normal pleopods on the left, and as they progressed to pretty severe and acute lesions, we were having massive gill and pleopod erosions, necrosis, and even what I described as this gill tree appearance seen on the far right, where the entire gill looks white and kind of highlights that gill structure. So by doing some wet mount cytology of the gills and pleopods, we can compare our normal gill seen at the top left with our severely compromised gill and pleopod on the right side. So we were seeing these non-linear branching aseptate hyphae that oftentimes replaced the entire gill filament that created that kind of gill tree appearance. And this pathogen did progress to systemic infection in some. I usually saw this as a liquefactive hepatopancreatitis, and we diagnosed this as Haliodicida noduliformans, which is a type of oomycete with a panfungal PCR. And as much as I want to highlight our successes, I want to highlight our failures as well. We tried a heck of a lot of things. We did several pilot treatments and ended up putting the cohort through a final treatment that was derived from pithiosis treatment in dogs, using oral itraconazole and terbinafine baths, which while it did reduce loads, it did not completely clear the oomycosis, and we ended up culling all of these bronchitis, infectious bronchitis cases. Once we were seeing the hyphae in the gills, it was sort of end of the road. And we have been seeing ongoing intermittent mortality in these species. I want to highlight that oral treatments and diagnostics are possible in these species for those of you who haven't tried. We typically use a metal feeding syringe, and you just pass it right through the mandibles. Use metal, not plastic. These species can and will bite through that plastic. And we've used this for both diagnostics, getting gastric lavage samples, as well as treatments doing oral metronidazole, oral itraconazole, et cetera. They also will and can bite, so just be aware of that. Diving into some general diagnostic techniques, I just want to highlight some tools to potentially add to your toolbox. So the first is gill endoscopy. We have been doing this usually in combination with a ketamine sedation. It's very size and species specific, whether you can get into that branchial cavity. I'm mostly doing it in our decapod crustaceans. But because these crustaceans have this lovely pro-PO system involved with creating melanization as part of that innate immune response, we have this nice visual representation of bronchitis seen as these black spots. And so, the clinical utility of this tool, we are still investigating, but it is just one more tool to add to your invertebrate toolbox. And we do a lot of hemolymph. A lot of these methods have been talked about and published previously, so I'm just going to gloss over this. Mostly we are doing total hemocyte counts, including cytospins, and doing biochemistry panels using the supernatant from a lithium heparin tube. AHEAD is very subjective information. However, I do think it is important to share. I want to make sure that, not having sufficient N with a lot of these species, our Japanese spider crabs and other decapod crustaceans in public aquaria doesn't stop us from sharing some of the trends that we're seeing. I really hope you all can help prove me wrong or prove me right. But this is really a call to share some of the trends that we are seeing and hope that we can start collaborating and get some objective data out of this. I'm really highlighting Japanese spider crabs here primarily because we do have a reference value paper. And I know several of you do have these animals in your collections, but these are really trends that we've been seeing for multiple different crustaceans. So first, looking at total hemocyte counts, we have the reference paper in purple on the far right. We have animals that at the time of collection we determined to be healthy and went on to survive in green. Of course, the caveat that we determined health as best as we could. And then animals that went on to die within 7 days of collection on the left in orange. And you see this notable hemocytopenia in the animals that go on to die compared to our survived healthy animals and the reference paper. Of course, hemocytopenia is a pretty well-documented phenomena in infected decapod crustaceans. Likely, a lot of this has to do with tissue recruitment and away from the circulating hemolymph. However, interestingly, not all of our hemocytopenic animals were infected or even had really notable inflammation. This does raise a question of whether there's concurrent immune suppression going on, but it certainly raises total hemocyte count as one potential prognostic indicator for outcomes. And when we look at the hemocyte differential, we have on the left an animal whose endpoint was being released onto exhibit, determined to be healthy, is alive and well. And on the right, we have an animal whose endpoint was dying, who is undergoing multiple treatments, has several legs missing, very severe black spot lesions. And what we see on the left are the trends that we most commonly see in health, which are far more agranulocytes than semigranulocytes or granulocytes. Whereas in disease, we see this increase, this relative increase of our semigranulocytes and granulocytes relative to our agranulocytes. Of course, this story gets a little bit more complicated as you start to tease into it more. So these are all individual animals who have hemolymph collections within 7 days of dying. And so I wanted to first highlight the ones circled in orange, and these kind of fit that picture where we see relative increases of our semigranulocytes and granulocytes in disease. But interestingly, when we have these really hemocytopenic animals, we actually frequently see these relative increases in our agranulocytes or hyaline cells. Agranulocytes are proposed to be involved mostly in phagocytosis, whereas our semis and our granulocytes are going to be involved a little bit more in the pro-PO system. Certainly, there's a lot more to explore here, but all to say that you really do need to evaluate the entire clinical picture, the entire hemolymph picture, and not just pull one value apart from the rest. And so I wanted to highlight this particular animal whose endpoint at the far right is actually being determined to be healthy. This animal came in with a total hemocyte count in the 200s. So I want to just first highlight that severe hemocytopenia is not a death sentence in these animals. This animal did have what we presume to be a bacterial infection based on findings on the cytospin, hemolymph characteristics. We did intervene with antibiotics, and we see over time, this animal's hemolymph improving a lot more closely, close to our reference values and to our conspecifics. But when we overlay AST over on this, we have the dotted line being the max AST value from the reference paper. Unfortunately, we are missing the AST from that first time point, but we see an elevation in that second time point. And as we move from left to right on this graph, this animal is clinically improving, went from being anorexic and lethargic to acting like a normal crab, eating really well. So we see the hemolymph improving with those total hemocyte counts, getting more agranulocytes, and we see this AST decreasing, which really made me want to evaluate AST further. Again, this is really early stuff. This is nothing definitive, but I really hope that this just encourages encourages us all to look. So in American lobsters, AST has been associated from the heart and the hepatopancreas more so than other tissues. And when we look at this box and whisker plot, we have animals that end up dying, not necessarily within 7 days, on the left in orange, followed by our healthy ones in green and reference in purple. And we see this relative increase in AST compared to our healthy conspecifics. Of the cases that we had hemolymph values within 7 days of dying, 4 out of 6 of these cases did have AST elevations and associated hepatopancreatitis. 2 cases that I want to highlight were 2 cases that came in. They died pretty soon after arrival from transport. They were in the same cohort. They both had nearly identical histologic lesions of severe chronic hepatopancreatitis, likely from a fungus. One animal had an AST of 1100, the other of 6. And although perhaps this means that this just is not a very valid marker in Japanese spider crabs, I do want to propose the potential that this represents something like end-stage disease, like we might see in end-stage liver failure in a vertebrate. We have seen elevations only with some cuticulitis. The lobster paper, did not evaluate cuticle as one of those tissue sources. It's possible we are missing tissue sources. We, of course, don't have the isoenzymes specifically from Japanese spider crabs. It's possible that there's transient changes in the muscle related to the hemolymph draw itself, multifocal lesions that we aren't picking up on histology. And of course, the potential that this isn't valid, it's not repeatable in the slightest, but I really just want to highlight that we need to look. I think we aren't doing enough looking in these species, and we're letting our small N numbers stop us from sharing some of these data. So all to say, our marine invertebrates require some creativity in terms of diagnostics and therapeutics. We have to try new things, and when you are trialing new treatments, as I demonstrated with the isopods, try it on a few animals first before you try it on a cohort. It's possible that hemocytopenia and elevated ASTs may be prognostic in Japanese spider crabs. There are certainly trends that I've been seeing in other decapod crustaceans as well. And it's really just to call us all to look. And there is a heck of a lot more work to be done. And we really need multi-institutional collaborations like that Japanese spider crab paper. The list goes on and on and on of potential things to work on. So if any of you would like to collaborate, you want to work on pushing invertebrate medicine forward, let's chat. Some references and a huge thank you to our benthic husbandry team. As you saw from our little honey goggles, they are extremely involved and have put in a heck of a lot of work with these animals. All right, thank you so much. Do you have any questions?
Okay, our next speaker is Dr. Hannah Dada. She graduated from UC Davis School of Veterinary Medicine in 2023 with an emphasis in zoological and aquatic medicine. During her 4th year of vet school, she accomplished the necessary requirements for the World Aquatic Veterinary Medical Association Certified Aquatic Veterinarian Program after completing various rotations, externships, and research projects focused on aquatic animal health. Following graduation, she completed a small animal rotating internship at the University of Illinois, Urbana-Champaign. She's currently the aquatic animal veterinary intern at SeaWorld San Diego, where she performed the research she will be presenting today. Her research interests include nutrition, reproduction, and emerging diseases in zoological animals. She looks forward to continuing her career in zoo and aquarium medicine with goals of practicing clinical medicine and relevant research to help conserve and protect our wild species. Dr. Dada will be competing in the student presentation competition. Please join me in welcoming her.
Thank you, Dr. Stevens. So today I'm going to be presenting plasma protein electrophoresis in the Eastern Pacific green sea turtle. And yes, we do have turtles on the West Coast. So what is protein electrophoresis, or EPH? It's a laboratory technique that separates proteins based on their electrical charge and size using an electric field. We typically think of gel electrophoresis, traditionally agarose gel electrophoresis, or AGE. And this is a laboratory technique used to separate molecules like proteins based on their size by applying an electric field through a gel matrix. Generally, this allows about 5 to 6 protein fractions to be resolved: prealbumin, albumin, alpha, beta, and gamma globulins. A newer technique used now in veterinary medicine is capillary zone electrophoresis, or CZE. This is a separation technique that utilizes an electric field within a narrow capillary tube filled with a conductive liquid or background electrolyte to separate charged molecules based on their electrophoretic mobility. This can yield up to 9 fractions: prealbumin 1, 2, and 3, albumin, alpha 1 and 2, beta 1 and 2, and gamma globulins. CZE has shown to use decreased labor, less assay time, and smaller amounts of sample are needed, which makes it really useful in a clinical setting. So why do we care about protein electrophoresis? Well, it's a better tool to quantifying albumin and globulin fractions in our non-traditional species. It is especially helpful for assessing immunoglobulins in acute phase proteins, as these proteins have been shown to have reactivity in certain reagents commonly used in our chemistry analyzers. EPH is not a new diagnostic tool for our green sea turtles. In fact, a previous study compared AGE and CZE in the Atlantic green sea turtle. They found that there was less overlap in these two types of electrophoresis, making the need for CZE reference intervals for this species. Another study looked at pulse field gel electrophoresis, a type of gel EPH, to create reference intervals for the Indo-Pacific green sea turtle found off the coast of Australia. This only yielded 5 protein fractions, but it did compare healthy and sick animals using EPH for the first time in this species. So if we already have the reference intervals, what are we doing here today? Well, I'm here to distinguish between the Eastern Pacific green sea turtle, Chelonia mitis agassizii, versus Chelonia mitis, the Atlantic green sea turtle. So studies have shown DNA differences between the Chelonia populations of the Atlantic Mediterranean region versus the Indo-Pacific region. Eastern Pacific green sea turtles are generally smaller and darker in color compared to their Atlantic counterparts, as you can see in the picture. They are also sometimes called black sea turtles, if you look that up on Google. And if you were to order an EPH or CZE from UMiami with just green sea turtle, you will get those Atlantic reference intervals. And if you were to put Pacific green sea turtle, you wouldn't have any reference intervals at all. Another important part of the study was looking at the clinical utility. So certain protein fractions have been shown to elevate with certain diseases and certain species. For example, FIP in cats, auriculosis, agglutinin disease, myeloma, lymphoma in humans, and aspergillosis in our penguins. This is an example of an electrophoretic of peritoneal fluid in a cat with ascites. There's a polyclonal gammopathy that spans the beta 2 and gamma region with an increase at the alpha 2 globulins. This is a typical electrophoretic of a cat with FIP and can be used to help diagnose this disease in this species. So the objectives of our study were to develop reference intervals for CZE in the Eastern Pacific green sea turtle. We wanted to compare these reference intervals to the Atlantic green sea turtle to see if we can define subspecies differences. And then next, evaluate the clinical utility in clinically ill individuals, where we can see maybe certain protein fractions increasing with certain diseases. So I utilized banked plasma samples at SeaWorld San Diego, where I sorted through hundreds of samples that were from known Eastern Pacific sea turtles from 2017 to 2024, preserved in our -80-degree freezer. This included samples from collection animals, rescue turtles deemed healthy enough to be released from rehabilitation, and captive-born sea turtles, some of which were released to the wild. They all had medical records detailing a clinically healthy status, meaning they had CBCs and chems within the reference ranges. They didn't have any evidence of pathologies externally, and they were eating and swimming normally. We then sent the samples to the University of Miami Avian and Wildlife Laboratory, where CZ analysis was performed. We then created reference intervals generated per the American Society for Veterinary Clinical Pathology guidelines using transform data and the robust method. For our results, we were able to create a CZE reference interval from 25 plasma samples. This yielded 9 protein fractions: prealbumin 1, prealbumin 2, prealbumin 3, albumin, alpha 1, alpha 2, beta 1, beta 2, and gamma globulins, the exact same fractions as the Atlantic green sea turtle for direct comparison. This is an example of a CZE and electrophotogram from a healthy individual. On the left, you can see the total protein and then the breakdown into the different fractions. And on the right is a typical electrophotogram where the different protein fractions are split up into different percentages to span the graph. We did not see significant differences between the Atlantic and Pacific green sea turtles. However, there are some differences present. So when you look at the alpha 1 and alpha 2 regions, there are slight differences in the upper and lower limits for the different species. The same can be applied to the percentage fraction breakdown, where one may see a higher comparison to the other, meaning that the CZE results for these reference intervals are still relevant. The next, we wanted to apply these to real life cases. So this is an example of a CZE on a gravid female. In this example, you can see there's elevations at the prealbumin 1 and prealbumin 2 fraction, or prealbumin 2 and prealbumin 3 fractions. This may be an acute phase reactant, something to look further into to see if there's elevations in other gravid animals. Prealbumin is a precursor protein, and in humans, it's been shown to elevate in pregnancy or steroid use. And so it might be beneficial when you don't have access to other diagnostics like imaging to diagnose an animal being gravid. With AGE, so an older type of electrophoresis, you tend to only get one prealbumin fraction where you might miss these elevations that we do see in CZE. I think this slide is the coolest thing I have for you guys, where we can actually see comparing the healthy and sick in the same individual. So I sent a second batch of samples to Miami with animals with known pathologies at different time points, and we're able to compare it to their healthy references. So in this example, on the far left, you're going to see a healthy sample from 2022 in this individual, where the alpha 1 region has a protein percentage of 6.9%. I'm sorry, it's really small. But then you can see in 2023, when this individual had known dermal wounds from probably getting bit from a conspecific, that alpha 1 region increased to 17.1%. The next year during its annual exam, we got more blood and we were able to see that decrease in the alpha 1 region when the animal was fully healed. So it's just showing the clinical utility in this diagnostic. So in summary, we were able to develop applicable reference intervals for 9 protein fractions using capillary zone electrophoresis in the Eastern Pacific green sea turtle. Electrophoresis is a key diagnostic tool for evaluating plasma proteins in our non-mammalian species. And CZE allows for more protein fractions to be analyzed compared to AGE. So this is another example of the same individual with the same sample having CZE and AGE performed. And you can even see a little increase in that prealbumin 2 fraction in the CZE that you don't get to see in the AGE because there's only that one prealbumin fraction. Preliminary data did not show significant difference between the 2 subspecies, but there might be slight differences making this of relevant use. CZE may be utilized to identify specific protein fractions that may be associated with certain diseases. And so our next steps are addressing the effects of season, sex, reproductive status, wild versus captive species in order to further this use in our clinical setting. I'd like to thank my co-authors, primarily Dr. Carolyn Cray at Miami for helping kind of guide this project, my staff veterinarians at SeaWorld San Diego, Dr. Herrick, Dr. Russell, Dr. Schmidt for being mentors and supporting me throughout this year, and then Dr. Robeck, our VP of Research and Animal Health, for approving this research. And then, of course, I'd like to thank all the technical staff at Miami and SeaWorld San Diego for helping me sort and analyze this data. And then SeaWorld San Diego for supplying the samples, and Miami for funding this project. Any questions? I can take one. Okay. Thank you.
Okay, our next presenter is going to be virtual. It is Dr. Daniel Garcia Paraga. He obtained his veterinary license and PhD in veterinary medicine from the Complutense University of Madrid. He is a European diplomat in the veterinary specialty colleges of zoo animal medicine and aquatic animal health. He's also the director of zoological operations at the Oceanographique of Valencia and the scientific director of the Oceanographic Foundation. He is also an inspector for AIZA, EAZA, and IAAAM zoological associations. Furthermore, he is a veterinary advisor at EAZA for the marine mammal tag and the Lasma tag. Dr. Paraga has over 100 scientific publications in index journals. Please join me in welcoming him.
Well, thank you. Thank you very much for the introduction. I really wish to be there with all of you, and I'm sorry not being able this year. I want to first thank my co-authors that helped me to develop this kind of technology to monitor animals, animal behavior and welfare, especially University Autonomous of Madrid and University Autonomous of Barcelona, together with NeuroGreenTech, that is the company actually the spin-off developing all the online platform and developing the software. So today I want to present about the use of activity trackers in how to monitor activity in our individuals. Activity trackers basically take accelerometry in 3 axes. And in our case, we'd also include temperature. Of course, there are devices much more complicated, adding magnetometry and other parameters, but we want to keep it simple in order to maximize the simplicity, the battery duration, and the treatment of data. So we basically found that the best device that we could find was this from Fibion Sense, this tracker. It's a medical device, very light. It costs around $150 and it can measure up to 12 times per second. So it achieves more than 1 million readings per day. Basically, the accelerometry in 3 axes and temperature is totally waterproof, which is good for our environment. And the main thing is that it can download information automatically through a cell phone into the cloud. So the information, as soon as the animal is out of the water, can be sent into the cloud. And with that, we can interpret it. The device is only 7 grams. It has its own internal memory capacity for 14 days. So in case there is no phone in the vicinity, it's able to store the information until one phone is close by, and then it uses the phone to send the information into the cloud. It takes like 5 minutes to download the information approximately into the cloud. And the battery lasts very long, actually around 6 months, which is very good because we don't have to handle the animal at any point, and just approaching the animal in less than 20-meter range, the information is automatically downloaded. It is conceived to be disposable, so the battery is not replaceable, and we are working with the company that makes them in order to figure out if we can make them well, basically rechargeable. The devices are approximately 2 inches in maximum length and 5 millimeters in thickness, and it's classified as a medical device in Europe. So basically, we attach it. It's developed for humans. You can see here in the lower picture that in the humans it's adhered into the tight with a sticker. In the penguins, we use zip ties because they have the wing bands. It's easy to attach to them, and we just use the cell phone as a bridge to send the information into the cloud. And once into the cloud, there is a platform to interpret the data. It's very important to remark that the devices are not capable to transmit the data from under the water. So for sharks or sea turtles, we need to remove the device in order to get into the surface in proximity of a phone, to download it into the cloud. The phone, you have to do nothing, just to have the application downloaded. And with that, as soon as the phone is in the proximity, we have it in the phones of the keepers. Also, we have a permanent phone in the penguin house. The information is uploaded into the web. Here is the raw data. So you have the graphs of accelerometry and z-axis and temperature. And here is basically the human algorithm is interpreting the activity through the day, from midnight to midnight of the next day. Because it's the human algorithm, you have the behaviors that are expected in a human: cycling, standing, high intensity exercise, walking, sporadic walking. So you can have a very good idea on what the animal, in this case, the person, is doing on a day-by-day basis. So far we work in the systems of placement in a safely way. I mean, the system comes with a battery, but it's good that the case is very sturdy. It's developed for kids and it's medically approved for kids, so it's not so easy to break. And also we are working on developing different species-specific algorithms, as well as the development of the platform to interpret that information in our best interest. We have tested it in many different species, from harpy eagles, sea lions, Dorcas gazelles, but it's true that in penguins are the individuals that we have more data. And we have a connection with different zoos in Europe that are collaborating with us in generating algorithms for the different species. The system that we are using to transform accelerometry into behavior, it's a random forest model with cross-validation to generate an algorithm through machine learning that can self-learn in order to improve with more data and more records added. So basically, we managed to transform the human algorithm that you can see in the upper part into a penguin algorithm to identify different behaviors. And nowadays, we managed to have an overall accuracy for 10 different behaviors, over 90%, with a K-PAP predictive value of 89.9%, which is quite good. Some behaviors are very, very accurate or precise in the detection, and some others are more tricky, like some agonistic or water grooming. But in general, the accuracy is very high. It's the power of the tool. It's great because basically these are two penguins on the same day. One penguin is spending a lot of the time in the water, while other penguin is spending all the time on rest, on land, lying or standing up. So we can actually compare and trying to enforce some animals to spend more time in the water when needed. For instance, Beethoven, you see in the yellow color of the cakes are the water time. You can see that there are some animals that really need to spend more time in the water, and we can actually establish individual activity budgets or times that we want them to spend in the water, and how we can enforce them to be more active. We can also evaluate the efficiency of enrichment with the different individuals. And you can see, for instance, in the upper diagram, how adding some ice trays in the water make the animals much more active in the water. We can also now try to implement systems to monitor sleep, like these chicks with electroencephalography device, or detect stressful situations like during incubation, like this ECG egg. We are trying to combine these technologies to see if with the activity trackers we can actually manage to record some additional events. So for instance, during incubation, we are trying to establish the budgets of time that males and females are incubated. You see here, for instance, in the two diagrams, how males and females switch to incubate the eggs. Of course, molting is a critical time. We can monitor also the behavior and how the animals spend laying down or standing up, and when they start to use the water again. And from medical purposes, also very useful. We see that, for instance, with some cases of aspergillosis, they decrease. They tend to spend more time laying down, and as soon as the treatment is established successfully, the animals start to be more active and use the water as well. So regarding the online platform, there are right now 5 zoological institutions in Europe that are participating on the different species with this device, and the idea is that this platform includes different animals for the zoo, where you can pick and choose your animal. Each animal has its own folder. And you can have also a sensor information display when you have reflected all the sensors that are placed in your zoo, how many sensors are active, inactive, the battery level of each of them, the memory capacity of each of them, last time that they were synced. And we can generate also an alarm display in order to pop up animals that are out of their normal range established for them, below or under. So for instance, if we say, let me know whenever a penguin spends more than 30% of the time laying down, it will come out automatically on the alarm display screen. Of course, we can go on a day-by-day ethogram for each individual. We can go even on each day in a minute-per-minute activity, or even a second-per-second activity. So we can click and go down and down to really go in detail on what the animal was doing on each second, actually. And we can, for given periods of time, we can also establish minimum, maximum, and average parameters. For instance, in surface swimming, this animal in the last 2 months, or in this time range, there was approximately 8% of the time swimming or surface swimming, with a maximum of 1 day having 26% of the time, and 1 day only having 1.5% of the time in surface swimming. So we can do it for the different behaviors. And here also we can compare one individual towards their own average. So here we set up 2 days, 7 days, and 30 days to establish the average activity for the individual. And we can just compare the individual data for that day of that individual with their average for the given period of time. And this is the same, but in graphic representation. The idea also in the future is that the application can send alarms to the phone, so you can generate veterinary alerts as soon as you find that one animal is not moving, or moving too much, or moving with under certain specific behavior. So the idea, what we are working now, is in different system device. This is an RP Hegel on Nuremberg Zoo, and with a special leg band where we are placing the device. We are working on attachment systems on different species. We are trying to correlate and identify sleep, not just resting, but actual sleep. Optimizing data analysis on how we present it to make it more useful for the user, and also setting specific alerts for activity or repetitive behaviors, or evaluation of temperature alerts. Also, very interesting, we are trying to implement these devices in objects to see, for instance, in toys, to check for global use along the day, if there are times of the day that the objects are more used, or the energy spent in the use of balls, hoops, or trays, or whatever element is in the enclosure of the individual, like nest cages or something like that. And also we are trying to work with the company on battery charge through induction or battery life. We have done some tests, and just double the battery can make the life to extend to 1 year, or even consider other sensors like ECG, oxygen saturation, or so on, no? And trying to also correlate with video trackers that we have in some facilities. And to finalize, just to wrap up, we think that this tool can be very interesting to save time and maintaining the animals recorded 24/7 in a standardized and treatable way. There is a potential individual for setting individual goals to achieve on a daily basis, or even energy goals that we want to get the animals to spend through a day. The system is very easy to use and totally automatized. It's very interesting that we can access the data from everywhere, because it's all online. So that's easy also to get it useful for whoever we decide to get that information to. And we are working on customizing the internet platform to take maximum advantage of the data recorded. So the idea is that our animal care teams can really dedicate more time on the animals and make it more efficient and sensitive in the detection of disease and monitor welfare. Thank you very much for all your attention, and thank you for all the supporter of the program, Madrid University, Barcelona University, and Eurogreen Tech. Here is my contact for any questions. Thank you.
Thank you very much, Dr. Braga. We have time for one question, if someone has one for him. They say that they miss you. All right, thanks again.
Thank you.
Okay, sorry everyone for going rogue on the schedule. I accidentally transposed my notes, and up next is Eric Gibbons. Eric is currently a fourth-year veterinary student at the University of Florida, earning the school's certificate in aquatic animal health. He'll be graduating in 2 weeks. Congratulations. And he will then begin a small animal rotating internship at Blue Pearl Tampa in the hopes of eventually getting into a zoo or aquatic specialty internship and potentially a CZM residency. He enjoys spending time with his cat named Scuba and doing wildlife photography, and he will happily show photos if asked. Please join me in welcoming the almost Dr. Gibbons.
All right, thank you for the introduction and thank you for having me. Today, we're going to talk about a new methodology to assess a group of animals that's often overlooked medically, and that's coral. And we can't talk about that without first talking about the stony coral tissue loss disease, affectionately known as Skittle-D. It was first seen off the coast of Florida back in 2014, and since then has spread in and around the Caribbean, affecting numerous countries and species of coral, specifically the hard reef building species. When combined with warming water temperatures, it's creating a large die-off of the Caribbean reefs. And when we actually look at the Skittle-D lesions, this is what we see. We see this bleaching and tissue loss running across the coral. And when we look at those active lesions histopathologically, you see lysis and necrosis of the gastrodermal layer. But coral can be difficult because polyps that are just away from the disease margins look grossly normal. And these chronically affected corals haven't really been evaluated. And when we look at the specific histopathological changes, you don't really see it other than at the active margins. So students from Nova Southeastern University sampled 90 colonies of Orbiceella faviolata over 1 year. It's also known as the mountainous star coral. And they were taken off marine sanctuaries off the coast of Florida. Depth, size, area affected were all logged, photographs taken, and multiple biopsies were taken, cord for histopath and to check for different omics, specifically genomics, metabolomics, and proteomics. And specifically, these cores were taken in areas away from the disease margins and grossly normal corals. The next step were for the slides to be evaluated by ACVP boarded pathologists. The 90 samples created 270 slides, which is a lot for one pathologist to look, especially when you don't know what you're looking at. The slides were evaluated for things based off the preliminary findings, specifically the amount of mucus hypertrophy and the changes to the endosymbionts like zooxanthellae. The evaluation showed general trends, but there were no clear cutoff values, being a subjective analysis. And this is where machine learning comes in. Now, you've probably heard a lot about AI, some good and mostly bad things, which is fair, but it has been shown to be a valuable tool when implemented to help corals, especially when it comes to monitoring for areas of growth, bleaching, and resistance to warming sea temperatures. But no one's used it to look at it histologically yet. And that's where the AI program HALO comes in. HALO is an assisted learning AI. I mean, before you can do anything with it, you must teach it what to look at and look for. It creates objective, non-biased, statistically significant pixel data, which is fancy talk meaning it's consistent. More than that, it's a rapid and sensitive way to evaluate large quantities of data all at once. And once it's trained, it evaluates with no changing bias. Think of it kind of like QPath, which is an excellent tool for evaluating slides. But while QPath works on detecting patterns, HALO uses an algorithm that uses shape, color, and size. It also has different modalities like an object phenotyper, which specifically looks at cells and nuclei. But before I show you how to teach the AI, I know most of you aren't looking at corals histologically on a daily basis. So here's a really quick rundown. The first layer at the top that has that darker blue color is the epidermis, followed by a connective tissue layer called the mesoglia. And then you have the layers of the gastrodermis, which line the gastrovascular cavity. And these are the also important layers that actually hold on to those endosymbionts like zooxanthellae. Then you have that basal layer of the gastrodermis, another layer of connective tissue of mesoglia, and then the clicodermis, which creates and holds on to the skeleton. And this is what training an AI algorithm looks like. It's all the art skill of someone who can only use Microsoft Paint. Each tissue layer becomes a classifier that the program will try to learn. He will read the different areas that you've selected from outside to in, relying on you to tell it which order to prioritize it. Think of it kind of like Photoshop or any other digital systems that create different layers and then stack on top of each other, creating one final image. That's what it does here. And then once you get it started, you teach it. And you got to teach it the good, the bad, and the ugly. So you can distinguish between healthy and unhealthy, and then pathology from artifact. So you keep defining more and more examples, let the program run and make its evaluations, and then see where it falls short. And it's important to get multiple slides and teach it multiple iterations. Because if you teach it 2 + 2 = 5, and like a child from say elementary school to high school, and then suddenly correct it and says, hey, it = 4, it's gonna have a really hard time unlearning it, even if the corrections are new and correct. So you teach it, you correct it, and then you start over from scratch and do it again. And then once you can get started, you can make smaller algorithms. While the previous one had, say, 8+ classifiers, dumb it down to 2 or 3 and make it really consider what you're looking at. So in this one, we're looking at just mucus, granular cells, or neither. And you can just focus on central areas instead of evaluating everything in a larger area. So for this project, we focus on making 5 different algorithms to look at these parameters. We have tissue layer identification, gastrodermal differentiation, mucosal hypertrophy, granular cell depletion, and endosymbiont counter. And tissue ID is probably the most straightforward, but also time intensive, but it's important for subsequent steps. You can see here with H&E on top and then the AI's evaluation on the bottom. Similar color scheme to before, with the epidermis being that dark blue color, the mesoglia being light blue, and then the clicodermis being that red. And what's really nice about these is these are all coronal cuts, which were the easiest to teach the programs to learn. And the one area that shines here is that it can actually distinguish between skeleton, which is lost during processing, so there's no stain uptake, and ocean water, which also has no stain uptake. And zooming in a little bit more, this is what I mean. So you have that skeleton on the left-hand side, the ocean water on the right-hand side in that gray, but then also it can distinguish the gastrodermal cavity, which again, it's a cavity, so it doesn't have any direct stain uptake there in the middle. Again, following a similar color style as I originally started with. Once we taught it the different layers, then we can do a further deep dive. And specifically, we looked at the gastrodermis, since that's where we saw the most pathology in both acute and chronic samples. So here we have H&E on the left, whether or not it is gastrodermis or not in the middle, with gastrodermis being that green color and then everything else being that gray. And then we separated the different layers out. So here we can look at the superficial versus basilar levels and the complete and incomplete mesentery. And then we can zoom in even more to show you it. And it's an important thing to mention here is that it's ignoring everything else that is not gastrodermis. As I mentioned earlier, we also made an algorithm to identify the mucosal hypertrophy, since those were the changes we originally saw in the preliminary findings. We also evaluated the granular cells, since those are believed to have an impact on the immune system of the coral, just to see how it changes with the disease states. And finally, the most straightforward is the endosymbiont counter. It's literally just find them all and then count it. And what's nice is we can stack these algorithms on top of each other. So instead of it just evaluating the entire polyp for how many endosymbionts there are or how much mucus there is, you can define the specific areas. So you can identify subclinical bleaching in, let's say, the basilar levels. Now this is all about Skittle D. So what are we actually seeing? We're seeing this marked coalescing mucocyte enlargement and rupture within the gastrodermis that is filling the gastrovascular cavity, with mesenteries being distended and disrupted. And you can see it's actually interesting, the top versus bottom image. Top image is a relatively unaffected coral and the bottom being much more heavily affected. You have H&E on the left, the tissue identification in the middle, and then the mucus evaluation on the right. An important thing to look at, especially in this middle column, is that dark green, that is the gastrovascular cavity. And you can see the distinction between the top and the bottom, where it's nice and open in the top image, and then it's very congested and squished on the bottom. And then when you look at the right image, just looking at the amount of mucus, you can see how much mucus is swelling within the coral, and just how much is taking over all the real estate. When it comes to stats, a full evaluation is still being done, but we have 2 preliminary statistically significant outcomes. The first is that there is a difference between the AI's mucus area and the locations and time periods sampled. The ECA is the coral reef ecosystem conservation area, with the other 2 being Lue Key and Sand Key. ANOVA statistics were run showing the biggest difference between time periods, especially with the secondary time period showing the most amount of difference. But as you can see, there is a significant amount of overlap. And secondly, there was a correlation between the AI's mucus evaluations of the gastrodermist and the pathologist's mucus hypertrophy score, which is good because that's what we'd anticipate. With there being a 2.3% increase with the AI score, with every increase score higher of the pathologist evaluations. But again, as you can see, there is significant amount of variation between the pathologist scores that's not solely explained by the AI's evaluation of the mucus area alone. So there might be a component that the AI is just missing, but ideally we'd have multiple pathologists going over these slides multiple times and getting a consensus statement and score that would be more consistent among all of them versus one pathologist one time through. This also has a few limitations in that it's the open ocean. We don't really know what's causing skittle-D. The best idea right now is it's a disruption of host endosymbiont physiology. But whether that's viral or toxic, we don't know. So whatever is causing it, it's likely affecting all of these corals affected. So it's not a true unaffected versus affected population. It's more of a healthy and more clinically affected population. Also, while pathologists can zoom in far enough to actually assess the endosymbionts themselves and see whether there's vacuolization or they're ghost cells, we can't zoom in that far. We're maxed out at 40 times magnification. So we can only really count the cells, but we can't actually go a step further and say this percentage is healthy, this percentage is not. With AI, there's a lot of talk right now about how valid it is, especially when it comes to scientific evaluations. If you heard about the large language learning models, there's something called hallucinations where they'll just create an answer and it's not based on anything. So there's this big concern about how accurate AI is. We've done all we could to make it as accurate as possible, controlling the inputs and outputs, readdressing them, correcting the problems, and then running them again. But it is just a computer program at the end of the day, and a human made it. So it is prone to inaccuracies, but we made it as correct as we could. For the next steps, this is all done with Nova Southeastern University to be with their different omics research when they're all cored together. As such, it's kind of relying on their data. So we're kind of waiting for their research to finish before we can actually put context to what we're seeing here. But on the bright side, Halo did come out with an update not too long ago that might be able to actually assess those endosymbionts. We can't zoom in any further, but it's getting a little bit better at that pixel data, evaluating between healthy and unhealthy. And then some final notes, especially with AI. AI has been taking jobs in multiple aspects of the modern life, and we do need to be cognizant of job security and what AI can mean for us in the future. But this program is currently pretty far away from that. It's a useful tool, especially when it comes to monotonous work or quantifying changes objectively. But at the end of the day, all it can do is make Excel sheets and pretty images. It takes a human to make the algorithm, interpret the data, and make subsequent decisions. But this project does show that using modern technology to craft evaluations of emergent diseases, even if they are in less traditional species. And with that, I'd like to thank my co-authors for all their help, especially Dr. Walker's lab for getting us all those samples, and Katie from the USGS for running stats. And with that, take any time if there is any. Take any questions. Yes. Yeah, so the question goes along the lines of more the environmental impacts and energy requirement to run AI. So if you're not aware, these bigger ones like ChatGPT, they require a whole bunch of energy and fresh water to cool since the processors are running that extensively. It actually is a big environmental concern. Luckily, with the program we're using, Halo, it's basically the same as running any kind of video game on a computer. It's downloaded to the software itself, and it's just that computer running it. So it's not as environmentally effective as the bigger ones like Google or ChatGPT are. Anything else? All right, thank you much.
Our next speaker is Elizabeth Fair. Elizabeth is a rising third-year student at North Carolina State University. She's originally from Miami, Florida. She completed her bachelor's degree in biology at Davidson College in North Carolina. Before starting vet school, she volunteered in public education at Zoo Miami throughout high school and worked on coral restoration projects in the Florida Keys and Bonaire. A fun fact about Elizabeth is that she is also a classically trained oil painter. Elizabeth is competing in the student competition. Please join me in welcoming her. Okay, can you hear me? Sorry, I'm not the same height. So I'll just dive straight into it. For those who are unfamiliar with Turtle Team, we are an NC State student-run volunteer organization that rescues and rehabilitates turtles in the Triangle region, which is Raleigh, Durham, Chapel Hill in North Carolina. It is our 30th year, and as of now, we've treated over 8,000 turtles, and we're currently in our busy season, so that number is just going up. We predominantly receive native turtles, over half of our patient caseload being box turtles. Occasionally, we do receive aquatics, and those are often either yellow-bellied sliders or snappers. And we do get the occasional non-native turtle, which is most commonly the red-eared slider. The red-eared slider is not native to North Carolina. It is in the native region for the southern Midwest, which is the yellow, orange, whatever color it decided to show up on the screen as. North Carolina is circled in the red. If red-eared sliders have been spotted in North Carolina, they're a prolific invasive species, and they were likely introduced as pets. But as of now, since they are classified as invasive, once they're brought into Turtle Team, we cannot release them. So we have been potentially interested in the idea of setting up a blood donor colony of the invasive red-eared sliders that get brought in. Here's our cute happy box turtle versus a sad box turtle crushed. The box turtles are commonly brought to us after being hit by a car. Naturally, they'll end up presenting with significant anemia. And so a blood transfusion can be extremely helpful. And while ideally you would have a species to species match, this is not always an option in a rehab setting. Turtle Team has a previous history of successful box turtle transfusions, and follow-ups months to years later, including today apparently, indicates that there have been no complications and the turtles are doing pretty well. Prior to each transfusion, a whole blood macroagglutination test was performed to test for compatibility. And we would like to know if it would be possible to use red-eared slider blood for a box turtle transfusion. This could offer a larger volume that can be safely taken from the donor, as for safety reasons, we don't take more than 1% of the blood volume from a box turtle. And in any rehab setting, and especially Turtle Team, a healthy box turtle donor is not always readily available. Before whole blood transfusions, a crossmatch is always ideal. So ClinPath 101. A crossmatch determines whether blood from the donor is compatible with the recipient. So in relation to blood transfusions, a crossmatch should be performed when naturally occurring pathogenic antibodies to foreign blood group antigens are present, such as in cats, or sensitization of an animal to foreign red cell antigens in a species without naturally occurring antibodies, such as in dogs and horses. So this means the production of acquired antibodies occurs, so you won't need to do a crossmatch for the first transfusion, but you should do one for every subsequent transfusion. Cross-matching detects incompatibilities between donor and recipient erythrocyte, or donor and recipient, that will not be evident on blood typing. And it's especially important since blood typing is not available against every blood group, just the major ones. However, cross-matching won't pick up on low titer antibodies, and thus it will not prevent a delayed type hemolytic transfusion reaction. There are two types of cross-matches. Your major cross-match is the most important one. This compares your donor erythrocytes to your recipient serum. You're checking for preformed, whether that be acquired or naturally occurring, antibodies in recipient serum against your donor erythrocytes. You will need red blood cells from the donor, whether that be whole blood or packed red blood cells, in EDTA or citrate, and serum from the recipient in a non-coagulant tube. Donor erythrocytes are then washed and incubated with your recipient serum. Your minor cross-match compares your donor serum to your recipient erythrocytes. It checks for preformed antibodies in donor serum that could hemolyze recipient red cells. This is less important because donor serum is markedly diluted after transfusion and is unlikely to produce a significant transfusion reaction. However, it could be important if you're transfusing a small patient in which hemodilution is less likely to occur. Washed recipient erythrocytes are incubated with your donor serum. Your mixture is then observed visually for hemolysis and microscopically for agglutination. Agglutination should not be confused for rouleau, which is a non-pathological finding, and unlike agglutination, rouleau should disrupt if your tube is shaken slightly. Any evidence of agglutination or hemolysis indicates incompatibility.
When there is a strong incompatible reaction on the major cross-match, donor blood should not be transfused under any circumstances. When there is an incompatible reaction on the minor cross-match, the transfusion can go ahead. However, if the donated serum is likely to contribute substantially to the plasma volume of your recipient, the serum should be removed from the donor whole blood, and then the packed cells, washed or unwashed, should be reconstituted in sterile isotonic saline before your transfusion. For our study, we used 20 turtles, 10 box turtles, and 10 sliders, and our sliders were a mix of yellow-bellied and red-eared. All turtles were either current patients of Turtle Team or in long-term rehabilitation or deemed unreleasable. We took no more than 1% of the body weight from venous blood, and we used a heparinized syringe and needle. At the time, all were deemed clinically normal by a thorough physical exam. However, since some were previous patients of Turtle Team, we had a few amputees and one red-eared slider who had methemoglobinemia or brown blood at the time of the blood draw, but was otherwise BAR. We will revisit that one shortly. Each turtle served as its own control and was randomly assigned for a cross-match with an individual of another species, and tests were done at 25 and 35 degrees Celsius. For scoring, macroagglutination reactions were graded on a scale of 1+, which indicated small agglutinates, or 4+ indicating one solid agglutinate. Microagglutination tests were either a positive for a reaction or a negative for no reaction. Here are results for slider donors to box turtle recipients. Only one box turtle reacted to a slider. Patient records indicated this box turtle had 2 previous cases of presumptive septicemia, and several weeks after this study, the patient presented back to Turtle Team with front limb edema and another episode of presumptive septicemia. We did have 2 albino donors who did not seem to make a difference, as neither box turtle reacted. The red-eared slider, who had methemoglobinemia, was able to receive and donate blood with no reaction. However, this slider did die several months after the study in April of 2025 and was presented for a necropsy, which indicated severe acute pulmonary edema and secondary severe acute pneumonia. These are our results for box turtle donors and a slider recipient. There were mixed results when using box turtles as a donor for a slider recipient. Not all of our sliders could receive box turtle blood. However, this is a less likely scenario considering the difference in patient sizes. The results are not on the slide, but there were no slider to slider reactions. 2 sliders receiving box turtle blood had a positive microagglutination test, but were negative for macroagglutination, which indicates you can potentially go forwards with a transfusion. However, caution should be taken. So go forward at your own risk. In conclusion, cross-match before a transfer if possible. Your sliders can be donors to box turtles. While not all box turtles can donate to sliders, that's kind of a less likely situation clinically speaking, as there is a significant patient size difference. Thank you to everyone who helped, especially to those who taught me ClinPath before I officially took ClinPath for this study. That was greatly appreciated. And we'd also like to thank Turtle for Every Log for bringing us the majority of the turtles we used in this study. References and questions? Okay, our final 2 speakers of this session are going to be virtual. They are Dr. Nora Hickey and Trevor Alexander. Dr. Nora Hickey is a fish veterinarian at the Aquatic Health Laboratory and the Aquatic Health Laboratory Manager at the Washington Animal Disease Diagnostics Laboratory, or WADL. And Trevor Alexander has a bachelor's degree in microbiology and is the Bacteriology Laboratory Manager at WADL. They are working together to provide specialized high-quality diagnostic testing for specimens from aquatic animals submitted to WADL. Please join me in welcoming them.
Good morning, everybody. Can you hear me? I assume you can.
I hear you, Trevor, and that's all that matters.
Excellent. Perfect. I'm going to get our presentation pulled up real quick. always a technical difficulty when my screen goes away. Hold on here. Okay. Perfect. Well, thank you, everybody. We are, I appreciate the introduction. I'm currently in Washington State, and currently Dr. Hickey is in Wisconsin, I believe. So we are tackling this remotely. So I don't know, Nora, if you would like to start us off, or I can definitely proceed.
I'll get us going. So the reason that we thought that this was an important presentation to do, and particularly for the IAAAM audience, is that to get good clinical results, it's really important to have good diagnostic test results, because there's the old saying, you know, garbage in, garbage out. And I think that people don't always know how to evaluate a laboratory and its ability to not just perform high quality testing, but also perform testing that is appropriate for, you know, the species that you're using. And I mean, we know this as veterinarians that, you know, what works for humans isn't always going to apply to some of our veterinary species, but that, you know, can go even further to be said about aquatic animals. And, you know, particularly in this presentation, we're really thinking about fish and invertebrates. And so we're hoping that, you know, at the end of this presentation, you'll have a better understanding of how to really select and use a diagnostic laboratory that's going to give you significant, high quality, interpretable test results. And we would very much welcome, you know, any additional questions at the end, and then also to follow up with us afterwards. And we will have our emails at the end of the presentation, because this is I think, a conversation, an area of understanding that's really lacking in a little bit in the fish community. So take it away, Trevor.
All right. Thank you for that. Okay. So really, to start this off is aquatic bacteriology is hard. Aquatic diagnostics is hard in general, and I'm sure most of you are nodding your head with that. There is a lot of information that we just don't know. A lot of pathogens that we just don't know, and that varies from species to species. And of course, looking for those pathogens can be very difficult depending upon what we are culturing and looking for. And I mean that just changes from animal to animal, from finfish to aquarium species, and from farmed animals. So there's just so much there that we're working with, that we're looking for. We're working with the veterinarians. We're trying to interpret the cultures and what we've grown and we're looking at. So it's extremely complicated. And so just wanted to start that off. It's hard. So going on to our next slide, just for evaluation of labs, is in looking at what they can and can't do for you, is do they have the ability to culture the pathogens that you're looking for? And that can vary, as I mentioned, from environment to environment, from marine fish to fresh water. Depending upon temperature that these fish are in, that can change the different bacterial pathogens. Commonly, we associate warm water disease with Flavobacterium pulmonare, and cold water disease with Flavobacterium psychrophilum. So, and of course, that requires different incubation temperatures, different media to culture those. So we really want to make sure that as a clinician, that you're making sure that the labs that you're sending your samples animals to can perform those diagnostic tests appropriately and can culture what you're suspecting. So I mentioned here, can we look for Vibrio species that require salt in the media to culture? Can your lab culture freshwater pathogens like, as I mentioned, Flavobacterium that requires a specific media to grow? Does the lab have the appropriate incubators to culture at the temperatures that is required for whatever submission that you're sending? So water temp, really important, because those bacterial pathogens have developed in that water and usually can only grow at the temperature that water is in. So if a diagnostic lab is used to working with terrestrial animals, your cat, your dog, your horses, their incubators are usually set up for 35 to 37 degrees Celsius, and which isn't appropriate for most aquaculture. So one of the things is to make sure that those labs have that ability to do that. So let's see here, going on. So thinking about that and their ability to culture that, is the next step is, can they identify those bacterial pathogens accurately? And there's a lot of different methods out there that you can do that. The traditional method is biochemicals, using sugars and reactions, and such as looking for enzyme production like catalase and oxidase to get to a genus and species identification of that bacteria. There's newer technology that's been around for a little over 10 years now, like MALDI-TOF, and of course there's PCR. But those diagnostic methods, one, need the expertise of the scientists that are performing those cultures to accurately identify. Do they have that expertise to understand how to identify and differentiate the different Aeromonas, Vibrio species from each other if they're working with biochemicals? Other things is MALDI-TOF. MALDI is a fantastic method of identification. It's quick, it's fairly accurate, but really needs to have the library for these aquatic pathogens in place. And what I mean by library is the library that comes with the machines historically has started off with human pathogens, and then as the years have gone by, they've been added, the manufacturers have added more and more bacteria to the library for identification of those species. But a lot of aquatic pathogens are not present in those libraries, or they're not present in high enough numbers to get accurate identification. So does the diagnostic lab have the ability, if they're using MALDI-TOF, to ID aquatic pathogens using their MALDI? And of course, having expertise with PCR. So a lot of times we could get to maybe a genus and we need to know the species level. And sometimes the only way to do that is by molecular methods. And that goes into, does that molecular department have the expertise to perform the right PCR methods? Sometimes 16S sequencing does not identify as well as other methods like RPOB for Aeromonas or Vibrio species. So having the lab understand that, hey, we need to do RPOB PCR for this identification is crucial. Having that expertise is really, really important and saves time, allows you to get results faster, and you can trust those results. Also, on top of that, there's all sorts of ancillary testing that really can help with the diagnostics, such as, can the lab perform histopathology? Do they have the expertise in aquaculture and aquatic organisms to perform histo accurately? Does that pathologist have that experience in that particular animal that you're submitting to look for diseases in performing histopathology. Also, does the lab have virology and parasitology? Because it's really nice to have a one-stop shop, right? So if something is indicated that, hey, we're going to be sending tissues and cultures to one lab, they can put the pieces together and create a nice report for you and help with interpretation of your cultures of the disease that is going on. And
I
by the
think,
way,
oh,
go ahead. I
Trevor.
was just going to say, Nora, if you would like to jump in anytime.
Yep, I was just going to chime in on that last part. You know, you're looking and seeing things like virology and parasitology, and I know that this talk is really focused on the bacteriology, but one thing I've appreciated during my time, you know, the 2 years that I've been working at Waddle after doing 7 years of clinical practice, is that it's frustrating for a laboratory sometimes to only get a piece of a diagnostic case. And when people send, you know, when clients are sending one test to one lab and one test to another lab, you know, another test to a third lab, sometimes I feel that we as a testing laboratory could do a better job if we had more of the diagnostic pieces of the case. You know, to provide you with a more complete picture. And so that's something that, you know, again, as a clinician, I didn't appreciate so much, but sitting at a lab, I've definitely seen how sometimes divvying up samples between labs for a single case, I think can provide a little bit less interpretation and context for test results. So that's next slide, Trevor.
All right. I mean, just going on top of that, as a bacteriologist, when I work with our aquatic cultures, the majority of these cultures are very interpreting them is very difficult. We're working with a lot of environmental organisms that are just, hey, they're normal flora in the water, but they can be associated with as a pathogen. And being able to talk with our pathologists and ask them about what they're seeing helps us determine the significance of that bacterial growth, helps us have a quicker turnaround time because we have that expertise and we're working together on these submitted cases. So as Nora said, it's really nice to have all of that here in one lab, because it really does help with interpretation of these cultures. So I mean, we don't have a problem reaching out and consulting with the submitters and trying to get that additional information, but it just does. It takes time. It takes we have to call, we have to consult, we have to take time away from the clinician, so to track them down and ask questions. So it is really kind of nice to have the ability to send and have all the diagnostics being performed in one place. All right, next slide. Let's see here.
One additional question to ask on top of their ability to work with aquatic organisms specifically is whether they have a quality assurance program. All testing laboratories are not the same, and really anybody could decide to set up a testing laboratory and you know, put out their shingle and provide testing for veterinarians. And you need to, especially because you're using either your client's money or, you know, you're really relying on those test results to make yourself look good, and to deliver your client, you know, accurate, you know, an accurate diagnosis and treatment plan. It's really, really important to have a laboratory that you trust to be providing you with high quality results. Things that you can ask about to kind of establish whether your laboratory has a quality assurance program are whether they do audits, and whether those are internal audits or whether they actually have external auditors come and evaluate them, because the audit you do in-house with your coworkers is going to be a little bit different than when people from another lab show up and are you know, really checking to see what you're up to. And I mean, they're looking to find things to write down and areas for you to improve. Does the laboratory have SOP review and approval? In particular, this is relevant for any import-export work. I don't know that public aquariums do this as much, but if you're a veterinarian working in aquaculture, you often will need to use a lab that's approved by USDA if you're doing any testing for international export. Does the laboratory have training, competency, and proficiency testing for the staff? Some laboratories will actually get external proficiency tests that, the staff doesn't know what the sample is, and they have to, come back with a test result that is then checked compared to that to make sure that they're, doing their work properly. And then, lastly, are their tests validated? Anyone can make a test for anything. That does not mean that that test is meaningful. And so, you're thinking of, for pathogens, we're thinking of things like sensitivity, specificity, limit of detection and things like that. And that's really important as well, because it's very profitable for laboratories to like come up with some new test, that's going to detect kidney disease in cats, 100 years before they even get it. But the question is, have they really done the work to show that that's going to be clinically significant and to help you understand what that test result means when it's positive and when it's negative? Next slide, Trevor.
All right. Okay, so after kind of evaluating and seeing how if the lab can really help you as a clinician, now it's time to submit. So we're going to kind of go through some of the basic things for how to submit and get the best results you can from the specimen that you submit. All right, so really sampling for success, the biggest thing is quality of your test starts as soon as you sample. So really, the preferred sample in any diagnostic lab is always going to be tissues and fluids, just because the amount of bacteria or pathogen present is going to be at the max level there. If you use a swab, you're only taking a very, very small amount of that sample, which means a lower amount of the pathogen, and which can limit the ability to detect that pathogen and to culture that pathogen. As a clinician, really, you should always be trying to submit tissues and fluids over a swab. Also, for aquatic submissions, some labs even will take in whole fish. Sometimes they're live fish, sometimes they're dead fish. And I know Nora would like to probably add to that.
Yep. Just a couple comments. You can, so you can obviously like aseptically remove tissues yourself. And that, I'm thinking, if you have like a fish with a skin lesion, maybe that you're submitting, or, you find something during surgery that you want to submit. But we have some clients who had pretty small fish that they were trying to take out kidneys and submit them for bacterial culture. And anyone who's had to deal with small fish knows it's pretty hard to aseptically remove a kidney, stick it in a Whirl-Pack bag to ship overnight. And you can guess that there probably was some bacterial amplification and growth during that process. And so I would really strongly recommend for smaller fish, if you do have the whole fish and you're really interested in bacterial culture, sometimes submitting the whole fish can result in a less contaminated culture. And, it's just going to be easier to grow and interpret.
Great, thank you. Just going to stress again, swabs, small sample size, reduce recovery of the organisms. A lot of questions I get is, hey, I have a biopsy or a small piece of tissue. How do I submit that? You can always use the swabs transport system and use that gel that's down in there to help maintain that viability of that tissue. But make sure if you're filling out an accession form to state that there's tissue in there, because a lot of labs will go, oh, it's just a swab. And in a pinch, if you don't have any sort of transport system, you can always use some sort of sterile container, like a red top tube with a little bit of sterile saline added in so that sample doesn't desiccate and dry out, because as soon as that happens, bacteria go with it. So that's always something that you can use in a pinch if you don't have
Hey, Trevor and Nora,
Yes.
you guys are at your 15-minute mark. So if you can wrap it up in the next minute or so,
Oh
that'd
my
be
gosh.
great.
Wow,
Yep,
we are.
we'll do that.
All
Trevor,
right.
pop ahead to the slides about the reporting and interpretation.
Yeah. Let's see here. Reporting and interpretation. So we're kind of talking about, we just skipped a whole bunch of stuff talking about susceptibility testing. So one of the biggest things for folks is they want susceptibility testing. And so talking with your lab and to determine what methods they use is really important, and how they interpret, because a lot of times you will get susceptibility, like, hey, these are resistant, susceptible, intermediate. But really in aquaculture, that's very difficult, because fish do not equal your cat, your cow, your human. And so a lot of times with interpretations, those interpretations are human interpretations, and fish are absolutely different than humans. So knowing what kind of results you're getting back and how to utilize those results is really, really important. Here at Waddle, we like to use what's called epidemiological cutoff values to help let you know if there is a resistant mechanism present. I have an example pulled up here with wild type and non-wild type. The non-wild type is indicating, hey, there's some sort of mechanism here that's letting these these organisms have a high MIC for that antibiotic. So it may not be the best antibiotic to use in that situation. So I'm being very, very short in this, and I would be happy to talk about this, or if you'd reach out to me via the email, because susceptibility in aquatic animals is a very, very complicated subject.
Okay, pop to our last slide, please, Trevor.
This is
with
the
our
last
emails.
slide.
Hey,
Or your
Nora,
emails?
sorry, we are out of
Yep.
time, but
Oh,
thank you
okay.
guys so much for your
Yep, thank you.
presentation. If there are questions regarding their talk, please reach out to them on the Whova app. Okay.
Thank you
And can I-
guys.
Thanks,
Sorry
Brittany.
to
Bye.
take up time.
All right, and if I could get one more round of applause, please, for all the speakers during this session. Everyone was great.
And a round of applause for Brittany for a valiant effort at keeping her session on time. So that's one thing about the virtual is we need to figure out maybe how to contact people if they're going a little bit over time. So thank you guys. Today is a half day. We do have the IAAAM business meeting. So if you're a full member, please stay. If you're a student, you're certainly welcome to stay, but you do not need to at all. If you have your badge, don't forget that the aquarium is allowing free entry this whole week. So now is your chance if you didn't get to look at everything the other night at the wonderful icebreaker.